Assalamualaikum. Hi. Today I'm Samsuizam bin Zainal, the student UTMSPACE Penang, will present about my PSM1 project that was supervised by my supervisor, Encik Muhammad Kamal bin Arifin. My title for PSM is one is for water cool system for clean room. Okay. Okay, so my presentation outline today will be the introduction, which is a background of study, definition of definition of the water cool system in the clean room, the problem statement, the objective, and then the scope of the study. Then the second topic will be the literature review, which is for the air conditioning design for clean room and the clean room regulation. Then the last one is the methodology, where I will brief about study review, then the building survey and data collection, the calculation, equipment installation, and the calculation for this PSM1. Okay, for introduction, the background of study is to design an air conditioning system for a clean room to meet the standard for the FE standard 209 A to D and the BS ISO 146441, then to design an effective complete water cool system for the clean room system. Definition of the water cool system is water cool is air conditioner that is superior to the air cool air conditioner which is operate at a lower condensing temperature. Water was higher specific heat compare the air because the efficiency is higher than the air. There is three type of the water cool air conditioner condenser, which is tube within a tube, which is in this design the inner tube is inserted into the bigger outer tube into the set of a coil to save the space. This is the most commonly used system that water will flow through the inner tube and cool the refrigerant. That refrigerant is also cooled by the air in the room. The inner tube can be designed to have a groove inner tube to increase the heat transfer between the refrigerant and the water. Then there is second is shell and coil. This configuration of condenser consists of a shell that can be a steel, which contain a coil of tube, which is usually made from a copper. Inside the coil to cool the hot gas refrigerant in the shell. Hot air is usually feed from the top of the shell and contact the coil. The gas that condense is further cool down into the subcooling state at the bottom of the shell. Then the last one is the type is the shell and tube, the most commonly used, like the heat exchanger. Then the chiller also have the shell and tube beside the shell and coil. This type of condenser here has a steel shell with many copper tube inside it. The cost to produce this is relatively high. It is only used in the higher capacity in conditioning system with a chiller 100 ton, 50 ton chiller. Water is circulate into the many tubes to cool the refrigerant that flow into the shell from the top. The shell also acts as a receiver. Then definition of the clean room. Clean room is what we call a controlled environment that has a low level of pollutants such as dust, airborne microbes, and aerosol particle, and also a chemical. That clean room has a very control level of contamination that specified by the number of particles per cubic meter at a specific particle size. The ambient air outside in a typical city environment that 92 degree dry bulb and 83 wet bulb is contain about 35 million particle per cubic meter. That is 0.5 micron and larger in diameter. Usually the test one you use 5 micron, 0.5 and 0.3. Then this is the clean room standard with ISO class 1. That one is a 10K clean room. That is a pharmaceutical and the food industry clean room. ISO 2, the 100K, also for the food industry and the pharmaceutical. ISO 3, 1000, 1000K. So it's for the some electronic, pharmaceutical and also food industry. Then ISO 4 is for the 10K, which is on our case, on my study one is ISO 10K one lah. Then to design a 10K ISO for this clean room, my problem statement is to design a one clean room 10K class 1 for AVX Manufacturing Malaysia Sunam Berhad, at Penang here, using the water cool system, cooling tower, chiller, water cool chiller, AHU air handling unit, dry cooling coil, and the filtration system. Total proposed clean room area for this problem statement is around 28,000 square feet, which using the walkable sharing space up the clean room area. Then this is the proposed layout with all the machine inside the clean room. All the level which have all the clean room area for this building. Then objective for my PSM1 is to calculate and determine all the heat load calculation, sensible, latent, and the total heat gain from all equipment, machine, electrical, building, people. Then to select and define a suitable water cool system for this proposed clean room. Then to such a chiller, AHU, air handling unit, dry cooling coil, a DCC, to meet the clean room specification, the clean room temperature, RH, and the dew point to avoid the machine condensate when shut down or not in use. Then to design a filtration to meet the clean room cleanliness specification. For this case, maybe we use a HEPA filter, the H class 1, and then the issue that G4 or G3, G9, that one we'll calculate later on the for the further discussion. Then scope of study for this proposal is for experimental purpose and research only. And then the clean room spec are based on the AVX manufacturing specification. It means the room spec, the RH is based on their spec, not follow for the other factory or other production area. Then this design calculation, equipment selection based on the standard clean room calculation on the carrier handbook and the GKR guideline one. Then the next topic is the literature review, which the air conditioning system, the basic air conditioning system for the clean room and the clean room regulation. So the air conditioning design for clean room, when it comes to the clean rooms, is more than the comfort. Is control environment. The clean rooms is control the temperature, the RH, the humidity, to the appropriate level of precision. Some plus minus 0.5 temperature, and then maybe 5% of the RH. Then in addition to the comfort, clean room air conditioning differentiate themselves from other conventional system with their increased air supply, which introduce the fresh air for the pressurization, for infiltration, and then to replenish back the exhaust that out from the clean room area by the machine. This increased air supply brings more air change. That's one we can follow the table back, 80 air change, 100 air change, 60 air change based on the clean room class. Then clean room air conditioning design is involve the knowledge of the regulation, the level guidelines, the airflow, the room pressurization, the temperature control, humidity control, and accounting the activity that taking place inside. Example as the electronic or pharmaceutical or food industry design. Then the temperature and like I said before, the temperature and the relative humidity for this clean room is very precise. That's a main factor to design this air conditioning system. Then the heat produced by the both user and the equipment must be compensated. So all the sensible or the latent heat must be compensated by the air conditioning. Therefore, it's important to know how many the people inside, the engineer, the operator inside, the working inside the clean room, and also the equipment in place and the heat is generated. Moreover, depending on the process taking in the clean room, sometimes the temperature and heat is very crucial, and it must be as precise as it. Then the most important thing is the clean room are held in the positive pressure, except from some what we call explosion proof or some chemical production area, which is mean the air will flow out of the room instead of in to the clean room. This one is to control the particle inside the clean room to make the clean room cleanliness. The proposed design for the aircon is responsible for creating pressure differential to keep the pressure cascade in between the division of the clean room and outside the clean room. Then for the clean room regulation, clean rooms and clean area are defined as having the following characteristic. There are three things that always keep a clean room clean: the internal surface of the clean room and the equipment within them. So maybe once of the week or once of the month they need to do the general cleaning, the technical cleaning at rest and as built condition. The internal surface of the clean room within or the area. Then the quality and the control of the air inside the room. They have to change the filter, the air issue filter, that's one. Then the way the clean room is operated, like the operator cannot wear makeup, they have to wear small jumpsuit inside the production area. To reduce the expenses of modifying the ambient temperature of humidity, the ASU or the system are designed to recirculate. Some use the low level circulation, and then about 80% of air through the room. Then another 20% is removing the particulate contamination as it generates, and while it's keeping the temperature and humidity stable. The particle, the contamination in the air tend to either float around if still circulate in the room. So most airborne particles will slowly settle with the settling depend on their size, either 5 micron, 0.5 or 0.3. Then a well-designed air handling system should deliver both fresh and recirculate filter clean air into the clean room. So if we flush the particle from the room, depending on the nature of the operation, the air when taken out of the room is usually recirculate to the air handling, where filter will remove all the particulates, high level of moisture, noxious vapor of gas of process, raw material, and sometimes when we want to control the RH, we use back the double coil ASU or we use the heater. That one depend on the energy saving or energy efficiency of the equipment. Then for the methodology, first one, I will do the study review. At the beginning, the study review been done in order to understand what is the requirement for the cooling load calculation. All consideration had been understood, such as the mean way to follow the carrier handbook or the train handbook and the JKR guidelines itself. After the study review had been done, data collection must be done to order to get all the data needed to do the cooling calculation, such as room dimension, proposed layout, been refer and then been calculate for the dimension, then record to do the building load one. Then the building material, electrical appliances, such as lighting spec and all machine specification has also been referred to do the cooling calculation. That one will refer back the table inside the carrier handbook. The building orientation, we refer to the plan and also have to refer the Google Map service, the east west west to define the shade and the solar radiation load. Then from the data being collected, the calculation we do the calculation process to covering all the heat gain from the solar radiation, glass, heat gain from light, electrical appliances, from machine, from the people, from the building itself, and then the outdoor air, sensible and latent. Then have to calculate also the humidifier, airflow, then same as the reheat capacity. Either want to use back the condenser water of the cooling tower for the double coil, or we want to use the electrical reheat system. And then from the total cooling load, when all have been calculated and determined, the type of the air conditioning system that can be suggested, then be selected. Then the criteria of the selected air conditioning type also been observed and analyzed to order to suit the room condition and the clean room specification. Then the conclusion is the data collection must be done first, then to study the spec that given by the client and to follow the standard requirement for the clean room, for the class 10K clean room. Then the calculation have been done based on the carrier handbook. Then we have to select the suitable and the correct equipment selection, not to vary upsize or oversize and not below size one. Then the most important thing one is to follow the standard and regulation to make sure the what we call the clean room can be this clean room can be operated as per the client spec and follow the NEBB test for the clean room specification. So that's all for today. Later we will meet again in the PSM2. We'll again I will present the detail of the calculation and all the spec that I have been collected during this PSM1. That's all. Thank you very much. Once again, I'm Samsu Izwan from UTMSPACE Penang. Thank you very much. Okay, bye bye.